So today what we're going to talk about are angles of a triangle. So we're going to start getting into triangles. And as we get into triangles, more and more and more ideas start becoming part of our everyday life. So we're going to talk about parts of a triangle. So we've got a lot of vocab for today. And again, sorry for the snafu on homework. It was written here. I don't know how I got the wrong dates, but I fixed it. Your only homework was page 71, right? So first off, what is a triangle? And you all have had experience with triangles. So what do you know about a triangle? Oh, it can't just be the Izzy hour. Alexis.
There's 3 angles.
It has 3 angles. Tina? No, not necessarily half a square. Okay, we actually don't know that yet. Okay, we will in a few minutes.
There are 3 types of angles.
3 types of triangles, yeah, okay. But we're just talking about the basic shape of triangle. So it has 3 angles. What else do we know about the basic shape of a triangle?
It has 3 sides.
It has 3 sides. Really, when we talk about definitions, we're very simple. What you guys are doing is getting deeper and deeper and deeper in. I'm just like, let's scratch the surface. That's all we're talking about. So a triangle is simply a 3-sided figure. If I could write normally. A 3-sided figure where each side meets at a vertex. It has a symbol. You'll never guess what it is. Holy gosh, you guys are so incredibly smart. Yes, it is a triangle. Okay? Nope, it is not a square. Okay? And we're going to name, and you're going to use all 3 vertices. Okay? So if I have this triangle, we'll call them XYZ. If I was going to name this triangle, I would say triangle XYZ. I could say triangle YZX. I could say triangle ZXY. And then I could go, I was going clockwise on all of those. I could go counterclockwise too. It doesn't matter the order of these 3 vertices because they are all consecutive because there's only 3 of them. Once we get into 4, we have to make sure that we don't go jumping across our shapes when we're trying to name them. Okay, they have to be consecutive, either clockwise or consecutive counterclockwise, starting at 1 vertex and then just going around. Okay, so that's our triangle. Now, I think it was Michaela that mentioned something about there's different kinds, and that's what we're going to be talking about today. So let me go ahead and, everybody good? Yep. Okay. So we have 2 ways to classify. We have classifications by sides. So the lengths of the sides name triangles different ways. So first we have something called a scalene triangle. And what is unique about a scalene triangle compared to other triangles? Rachel E.
None of the angles are equal to each other.
What else?
They're different lengths.
Okay, now remember we're talking about sides, so we focus in on the side component. So she said the lengths aren't equal, so I'm going to translate that into no sides are congruent. So we would have something that would look like this, where this is 1 length, this is another length, and this is a 3rd length. So the number of hatch marks talks about they are not the same unless the number of hatch marks match. Okay. The next one is an isosceles triangle. And by the way, I do have to say even though I am a math teacher, I really kind of have issues with spelling. And vertical angles is CAL, not CLE. So I'm going to correct it every single time, and if it gets annoying, I'm going to start taking points off. Isosceles, scalene, all these names are based on the Greek language. So yeah, they don't look like normal everyday language, but learn to spell them. Okay. So an isosceles triangle, what's true about an isosceles triangle? Michael?
Only two sides are congruent.
And I'm going to disagree with your response. Drake P? That's the language I need to hear. At least two sides are congruent. Which means all three sides could be congruent and it still would be called isosceles. Okay? So a picture of this one would be, this is our stereotypical one. So we got two sides that are congruent. We have maybe the third side isn't. Or this guy's also considered isosceles because he meets the definition. Okay? Now, that last picture is got a special name. What kind of triangle is it when all three of them match up? Sarah O?
An equilateral triangle.
That's your equilateral. Equal lateral sides. Equilateral triangle. All three sides are congruent. So again, he is equilateral. So notice that isosceles sometimes overlaps with equilateral. Okay, but equilateral doesn't overlap with isosceles because equilateral must have three congruent sides. And neither one of them overlap with scalene because it can't have any sides that are the same. Okay? All right, let's talk about classification via angles. Okay. Now, we base the name of the triangle on its largest angle. Okay. So, if our largest angle is under 90 degrees, then we have what's called an acute triangle. And since the largest angle is acute, that means the rest of them have to be acute as well. Nope. Let's put that A with that cute. So it's one word, acute. They're all acute. Cute little angles. Okay. Then if our largest angle is over 90, we would have an obtuse triangle. So largest angle is obtuse. If our largest angle is a right angle, then we have a right triangle. So, and how many right triangles could you have in, or right angles in a right triangle? One. Okay. And then the type of angle that goes along with equilateral is equiangular. Equa meaning equal, angular angles. So that one we have all the angles are congruent. Okay, so we're actually going to come up with a proof to go along with that. Now, everybody good? Ready? Yes? Okay. So I am going to add a vocabulary word that you will, something that shows up in a diagram sometimes. The way that a shape is not enough sometimes for us to write a proof. So what we can do is add something called an auxiliary line. And that auxiliary line will help form angles that we have a relationship with, alternate interior, same side interior, corresponding, and we can use our idea about parallel lines to help us prove some things. So an auxiliary line is a line added to a diagram to help in a proof. So without this addition, you actually probably couldn't prove anything, and it's usually dashed. So something like this going on. And so I'm going to do a proof of the theorem we're going to talk about, and you'll see that auxiliary line being placed in. So in your proofs in which you are given the diagram, the auxiliary line will already be there, but you're going to have to prove what allowed you to draw it. Okay, and that's the hard part about auxiliary lines. You just don't get to use them. You have to first give a reason why you can use them, and then they're good to go. So Theorem 311 now finally states this information that you've known for quite a while. The sum of the measures of the angles of a triangle is 180 degrees. Okay, now you probably learned that a long time ago, but now in our book we can actually accept that and we can use it. Okay, so I'm going to give you a proof on how this is done, and then that will be the end of our notes for today. So let me know when you guys are ready, because I'm going to go to the next screen for the proof. Oh, well, if Aiden's ready, then we're all ready, right? Okay. All right, so what we're going to do is do the proof of Theorem 311, so we won't be able to use it. So we're going to prove how we know that the sum of the angles of a triangle is equal to 180. So we want to prove that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. So here's our triangle A, B, C. And in this triangle are our angles 1, 2, 3. So as you can see, there's nothing here for us to use as a proof, right? So that's when we see an auxiliary line added. And the only way this auxiliary line is going to help us is, what relationship do you think that auxiliary line has to the side AC of the triangle? Drake, see?
It's parallel.
Yeah. We would need to have a parallel relationship going on. Okay? That's the only way that this is going to give us anything. Because notice what we have. Look at the top. Angles 4, 2, 5. What do you notice about them? Dakota.
4 is congruent to angle 1 because A and B is transversal to E.
Okay, so we have some alternate interior angles, but hold on. That's not the question I asked. My question is, what do you notice about angle 4, 2, and 5? Those three angles to each other. John.
5 to 2 are.
Nope, you're not answering my question. All three of them together. What do we notice about those three angles together? Lauren T.
They're supplementary.
No. They are not supplementary. Okay? Matt C.
If you add them all up, it's 180.
How do you know that those three angles, 4, 2, and 5, add up to equal 180?
That's that line.
We have justification. We've learned about it. Flint?
So that line is the straight angle.
We have a straight angle, so what allows us to say that the angle measure 4, 2, and 5 add up to equal 180? Mikey.
Angle addition postulate.
Angle addition postulate says if I have angles that add up to form a straight angle, then I know they add up to equal 180. Okay? Then there's other things we know if our auxiliary line is parallel to the base of our triangle. Angle 4 and 1 are congruent because they're alternate interior angles. What else? 5 and 3 are going to also be. So now I could substitute in angle 1 for 4, angle 3 for 5, and I've got measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180, and I've got my proof. Okay? But without that auxiliary line, I couldn't do any of this. So when we're doing our proof, I have to give a nod to that auxiliary line. So we're going to say exactly how to draw that line. So we're going to draw line DB so that line DB is parallel to line AC. Now, even though AC is a segment, it's part of a line. So what allows us to draw a line from a point not on the line so that it would be parallel to the given line? Okay? It's not a construction, it's a theorem. Okay? Sydney, you got it?
Through a point outside a line, there is exactly one line parallel.
Exactly. Through a point, and here I'm showing you how I abbreviate, through a point outside a line, there is exactly one line parallel to the given line. So that's theorem 3-8. We haven't had to use him before, but now he was vitally important. The only way I can use an auxiliary line is I must give a reason why I can use it. All right. Now that I know that I have parallel lines, I have a whole bunch of stuff that I could do. So I could say that, let's see, measure of angle 4 plus measure of angle 2 plus measure of angle 5 equals 180. Now that doesn't go from the what's up in the front. And notice that the given's not showing up in this. Who really cares if we have a triangle, right? Okay, but because we have a triangle, when we get to our conclusion, we will have proved theorem 311. So that's just angle addition postulate. Okay, and then we can say that angle 4 is congruent to angle 1 at the same time that we can say that angle 5 is congruent to angle 3 because they're the same reason. If two parallel lines cut by a transversal, then alternate interior angles are congruent. Now, in order to get step 3 to talk to step 2, I need to go from congruence into equality. So measure of angle 4 equals measure of angle 1. Measure of angle 5 equals measure of angle 3. And that's definition of congruence. And now I can substitute. So where I had measure of angle 1, I can put in, or measure of angle 4, I can put in measure of angle 1 in step 2. Measure of angle 2 stays himself. And then I can replace measure of angle 5 with measure of angle 3. And that would be substitution. Property of equality. Now, multiple ways to do this, but that one works just fine. Okay? And that's it. That's all we have to do. If I have numbered angles, I use the numbers. All right? That's it.